In the next example, we are given three geometric series and we are asked to determine whether sum to infinity exists for each of them. Now let's start with the first geometric series. To determine whether sum to infinity exists, what we need to do is to compute the common ratio and find the absolute value of that. Now if the absolute value is less than 1, then we can conclude that sum to infinity exists. So let's find out what R is. Okay, we can find out R by taking second term divided by the first term. So R will be 6 over 5 divided by 1, which gives you 6 over 5. So absolute value of R will be equals to absolute value of 6 over 5, which is equals to 6 over 5. Therefore, we can conclude that absolute value of R is actually greater or equals to 1. The series diverges. So S to infinity does not exist. Now we do the same thing for the second series. We find R. R will be term 2 divided by term 1. So we have 1/3 divided by 1, which is actually equals to 1/3. And the absolute value of R will be equals to absolute value of 1/3, which is equals to 1/3. And we can conclude that absolute value of R is less than 1. So the series converges. Therefore, the sum to infinity exists. Example is a little bit tricky. As you can see, it's expressed using the sigma notation, but no problem, we can work this out. So our first term is actually equals to -1 raised to the power of 1, and our second term is -1 squared. Our third term is -1 raised to the power of 3, and so on. We don't need to expand the entire thing. Anyway, there's no way to do that because it's sum to infinity. So next, what we need to do is to find out value of R. So R will be equals to -1 squared divided by -1. Okay, if you're not comfortable with working with this, you can simply express -1 squared as -1 times -1. So you realize that we can actually cancel a pair of them and end up with -1. So absolute value of R will be equals to absolute value of -1, which is equals to 1. And we can see that absolute value of R is greater or equals to 1. So therefore we can conclude that the series diverges. Sum to infinity does not exist.